NASA has revealed that a massive asteroid capable of destroying entire planets is hurtling through space towards Earth, dubbed the Planet Killer. This ominous celestial object is said to be larger than any previously recorded asteroid, and if it collides into Earth, we could be looking at doomsday in just a few months. The question that remains is this true? And if it is true, what does it mean for the human race? Watch till the end of this video to find out. Threat history. There have been several instances of objects falling from space and impacting the Earth. These include meteoroids, asteroids, and comets, but for the sake of this video, we will only be covering asteroids. To start off, what exactly is an asteroid? Asteroids are small rocky bodies that orbit the Sun, known as minor planets or planetoids. They are made up mostly of rock and metal and can range in size from a few meters to hundreds of kilometers in diameter. Most asteroids orbit the Sun in the asteroid belt, a region between Mars and Jupiter. However, some asteroids have orbits that bring them closer to Earth and are called near-Earth asteroids or NEOs. Asteroids are believed to be leftovers from the formation of the solar system about 4.6 billion years ago. They can provide valuable information about the early solar system, and some asteroids contain valuable resources, such as water and metals. NASA's discovery. Asteroids are known to have collided with the Earth in the past and may do so again in the future. NASA and other space agencies monitor the skies for near-Earth asteroids and work on developing methods to deflect or destroy any that may pose a danger to our planet. The asteroid was first discovered back in November of 2022 and was named 2022 AP7. In a study published in the Astronomical Journal, scientists from the Carnegie Institution for Science revealed they had discovered 3 large asteroids in space. One of these, the 2022 AP7, was then identified as a potentially hazard asteroid, PHA, as it crosses the Earth's orbit. The study's lead author, Scott Shepard, and his team made this discovery when they were looking for space rocks in the orbits of Venus and Earth. In Shepard's words, any asteroid over 1 kilometer in size is considered a planet killer. He further added that if an object of that nature were to hit Earth, it would cause significant damage to life and the environment, releasing dust and pollutants into the atmosphere, which would remain for a prolonged period. The Earth's surface would likely cool significantly from sunlight not getting to the planet. It would be a mass extinction event like hasn't been seen on Earth in millions of years, he said. But don't worry, he also added that it has no chance to hit Earth currently. Shepard noted that gradually the asteroid will begin to cross Earth's orbit closer to where the planet is located. However, he also mentioned that this will occur many centuries in the future, and currently, the orbit of 2022 AP7 is not known accurately enough to determine potential dangers in the distant future. Magnitude of the threat. Since then, NASA's experts have warned of the magnitude of the asteroid, saying that it is the largest they have seen in over 8 years. The potential of this asteroid to cause catastrophic damage, should it collide with our planet, is cosmic. It was the highest PHA discovered in an asteroid since 2014, and researchers said it was in the top 5% of the highest phase ever found. But when is it due? Well, so far, the exact date of its arrival is unknown, but experts are closely monitoring its trajectory as it continues to bear down on us at an alarming rate. Will we be able to stop the impending doom, or will we meet our demise at the hands of this ominous asteroid? Only time will tell, but one thing is for certain. The fate of humanity hangs in the balance as the planet killer bears down upon us. The planet killer asteroid is estimated to have a diameter of approximately 1.5 miles, making it larger than any previously recorded asteroid. Its size and speed make it capable of causing widespread devastation if it were to collide with Earth. NASA, along with other space agencies, is closely monitoring the asteroid's trajectory and working to determine the best course of action to potentially deflect or destroy it before it reaches our planet. The agency scientists have been studying the asteroid's composition and potential impact trajectory in the hopes of finding a way to prevent the potential catastrophe. The agency is also warning the public about the asteroid and encouraging them to be prepared for any potential impact. Future plans and collaboration. According to Shepard, the team anticipates discovering a few more near-Earth objects that are at least 1 kilometer in size, which have the potential to cause significant damage to the planet in the upcoming year or two through their survey work using the Blanco 4-meter telescope in Chile. Jay Tate, the director of the National Near-Earth Objects Information Center in Wales, said he is not concerned about 2022 AP7, pointing out that the Earth is a very small target. He added that the probability of impact is currently low, but not insignificant. Back in September, NASA launched the DART mission, which involved crashing a spacecraft into an asteroid in an effort to alter its orbit. The mission was designed to test technology that could be used to address space rocks that pose a threat to Earth, and it was deemed a success. Tate mentioned that an approach like DART may not be suitable for 2022 AP7 due to the size of the asteroid, but there are other potential methods. He also said that there is plenty of time to address the situation, and that it may be possible to use multiple DART-like impacts to gradually change the asteroid's path. Whatever the case, the researchers are determined to find a solution to this impending catastrophe, but time is running out. The asteroid is set to collide with Earth in the near future, and the fate of humanity hangs in the balance. This is especially the case at NASA because NASA has had a long history of studying asteroids. It began with the launch of the Near-Earth Asteroid Tracking (NEAT) program in 1995, which used telescopes on Earth to search for and track near-Earth asteroids. Since then, NASA has launched several missions dedicated to studying asteroids, including the Near Shoemaker mission, which orbited and landed on the asteroid Eros in 2001, and the Dawn mission, which studied the asteroid Vesta and the dwarf planet Ceres in 2005. NASA's efforts and preparedness. NASA's Jet Propulsion Laboratory, JPL, established the Near-Earth Object Program Office, which is responsible for identifying and tracking asteroids and comets that pass near Earth. The program also works to understand the potential hazards posed by these objects and to develop methods for mitigating any potential impact. In September 2021, NASA launched its DART, Double Asteroid Redirection Test mission, which aimed to crash a spacecraft into an asteroid named Didymos in an attempt to deflect it from its orbit. This mission was an attempt to test technology that could eventually be used to tackle space rocks that pose a threat to Earth. NASA's focus on asteroids is not only to study them and understand their properties, but also to protect the Earth from potential impact events. NASA's Planetary Defense Coordination Office, PDCO, is responsible for identifying potentially hazardous asteroids and comets, and developing strategies to mitigate the potential impact threat. But is this the first time that an asteroid has posed a threat to Earth? To answer it simply, no. Asteroids have been present in our solar system since its formation, and over the years, many of them have been found to be on a collision course with Earth. One of the first recorded asteroid impacts on Earth was the Tunguska event in 1908, where an asteroid exploded in the atmosphere above Siberia, flattening over 800 square miles of forest. The Tunguska event was so powerful that it caused the sky to light up for as far as 1,000 kilometers away. The explosion was heard over 600 miles away, and seismic waves were recorded as far away as England. At the time of the explosion, the region was largely uninhabited, so there were no reported human casualties. However, reindeer herders in the area reported seeing a bright light in the sky and feeling the heat from the explosion. The explosion caused significant damage to the forest, flattening trees in a radial pattern. The cause of the Tunguska event was initially a mystery, but it was later determined to be caused by an asteroid or comet about 120 feet in diameter that entered the Earth's atmosphere and exploded about 5 miles above the ground. In 2013, a small asteroid named 2013 TV-135 passed alarmingly close to Earth, coming within 4.2 million miles of our planet. At the time, the asteroid had a 1 in 63,000 chance of impacting the Earth on August 26, 2032. This caused concern among scientists and led to further observations and analysis of the asteroid's orbit. preventive measures, and collaboration. In the end, the likelihood of a collision with a large asteroid is relatively low, and NASA and other space agencies are actively monitoring the skies for near-Earth asteroids and working on developing methods to deflect or destroy any that may pose a danger to our planet. NASA has several strategies in place to detect and track near-Earth asteroids, NEAs, that could potentially collide with Earth. These strategies include surveying, for which NASA uses telescopes and radar to scan the skies for any NEAs. This helps to identify any asteroids that are on a collision course with Earth and to estimate the size, composition, and orbit of the asteroid. NASA then tracks the position of the identified NEAs to determine if they pose a danger to Earth. In the case that they do, NASA has researched different methods to deflect an asteroid if it is found to be on a collision course with Earth. These methods include using a spacecraft to collide with the asteroid and alter its trajectory, or using a gravity tractor to nudge the asteroid off course using the gravitational pull of a spacecraft. However, if all else fails and an asteroid collision occurs, NASA has also researched methods to mitigate the effects of an asteroid impact. This includes developing plans to evacuate affected areas and studying the potential effects of the impact on the environment and human population. International collaboration is another one of NASA's strong suits. NASA works closely with other space agencies and organizations around the world, such as the European Space Agency and the International Asteroid Warning Network, to coordinate efforts in detecting and mitigating the threat of asteroid collisions. All of these efforts are still ongoing and improving as time progresses, so there is hope for the future. In addition, the likelihood of a collision with an asteroid is relatively low, but it helps to know that NASA and other space agencies are actively monitoring the skies for near-Earth asteroids and working on developing methods to deflect or destroy any that may pose a danger to our planet. With the increasing awareness of potential asteroid threats, coupled with advancements in technology, efforts to monitor and mitigate the risk of asteroid collisions have intensified. NASA, as a leading authority in space exploration and planetary defense, plays a pivotal role in these endeavors. Through its robust infrastructure, extensive research initiatives, and collaborative partnerships, NASA remains at the forefront of asteroid detection and deflection strategies. One of the primary focuses of NASA's asteroid mitigation efforts is the development of innovative technologies and techniques for detecting and tracking near-Earth objects, NEOs. The agency utilizes a combination of ground-based telescopes, space-based observatories, and radar systems to survey the skies and identify asteroids that pose a potential hazard to Earth. These observations provide crucial data on the size, trajectory, and composition of NEOs, enabling scientists to assess the level of threat they may pose and formulate appropriate response strategies. In recent years, NASA has also invested significantly in spacecraft missions designed to study and characterize asteroids up close. By sending probes to rendezvous with these celestial bodies, scientists can gather invaluable data that enhances our understanding of asteroid composition, structure, and behavior. Missions such as OSIRIS-REx, which successfully collected samples from the asteroid Bennu, and the upcoming Lucy mission, which will explore multiple asteroids in the Trojan asteroids, are prime examples of NASA's commitment to asteroid research. Furthermore, NASA is actively involved in the development and testing of asteroid deflection technologies. Projects like the Double Asteroid Redirection Test, DART mission, aim to demonstrate the feasibility of altering the trajectory of an asteroid by colliding a spacecraft with it. By studying the effects of such impacts, scientists can refine deflection strategies and enhance our ability to mitigate potential threats from NEOs. International collaboration is another cornerstone of NASA's asteroid mitigation efforts. Recognizing the global nature of the asteroid threat, NASA works closely with other space agencies and international organizations to coordinate observation campaigns, share data, and develop joint initiatives aimed at safeguarding the planet. Partnerships with agencies like the European Space Agency, ESA, the Japan Aerospace Exploration Agency, JAXA, and the International Asteroid Warning Network, IAWN, facilitate information exchange and enhance the collective ability to detect and respond to asteroid hazards. Moreover, NASA collaborates with the scientific community, academia, and industry partners to leverage expertise and resources in asteroid research and mitigation. Through collaborative research projects, workshops, and conferences, NASA fosters innovation and knowledge sharing in the field of planetary defense, ensuring that the best minds and technologies are engaged in addressing the asteroid threat. As part of its broader planetary defense strategy, NASA also conducts risk assessments and scenario planning to evaluate the potential consequences of asteroid impacts and develop contingency plans. These efforts involve modeling the effects of different impact scenarios, assessing the vulnerability of various regions to asteroid strikes, and identifying strategies for mitigating the impacts on both human populations and critical infrastructure. Despite the progress made in asteroid detection and mitigation, challenges remain in effectively addressing the asteroid threat. One of the key challenges is the vastness of space and the sheer number of asteroids that populate it. Despite significant advances in observation technology, there are still gaps in our ability to detect smaller asteroids or those with erratic orbits that may pose a sudden threat. Another challenge is the limited capability to deflect or destroy asteroids on a collision course with Earth. While concepts like kinetic impactors, gravity tractors, and nuclear explosions have been proposed as potential deflection methods, their effectiveness and feasibility in real-world scenarios remain subject to further research and development. Moreover, the unpredictable nature of asteroid impacts and the inherent uncertainties in orbital predictions pose significant challenges to effective decision-making and response planning. Rapid advances in computational modeling, artificial intelligence, and data analytics may help improve our ability to forecast asteroid trajectories and assess impact probabilities more accurately. In conclusion, now that we've discussed everything about the asteroid, does the prospect of it hitting the Earth ring any bells? Perhaps one of the recent movies called Don't Look Up? Well, if you haven't watched it, Don't Look Up is a satirical comedy drama film. The plot centers around an astronomer who discovers a giant asteroid that is set to collide with Earth in 6 months. The lead scientist embarks on a media tour to warn the public and gather support for a plan to divert the asteroid, but faces resistance from politicians, the media, and the general public. As the asteroid approaches, the characters face a series of comedic and dramatic challenges as they try to rally support and prevent the impending disaster. The plot also explores themes of media manipulation, political corruption, and the impact of technology on society. The characters must navigate the complex web of lies, misinformation, and apathy that surrounds the asteroid threat. And ultimately, the fate of the world is left in their hands. With the current state of affairs, it seems as though Don't Look Up was more of a prophecy than a film, because soon after an asteroid was detected. The lesson we need to take away from the film is to believe scientists when they tell us of an incoming catastrophe, so that the world's leading governments can pull their resources to save the world, even if just in the nick of time. That's all for today. Thanks for watching, and we'll see you next time.